Hello and welcome to Easy as Pie with Mr. Carpenter. I'm Mr. Carpenter, and today we're looking at the zeros of expressions and functions. And this is a very pivotal idea in Algebra 1 and Algebra 2 that's going to show up a lot. So it's important that we have a good understanding of it. So it starts off with our friend, the expression, right? In other words, expressing itself in a unique way. So, for example, x plus 4, that's an expression. And with expressions, we can evaluate them for any value of x we want. So let's say we evaluate it for x equals 2. So we plug that in, 2 plus 4, and that'd be 6. But let's say we evaluated this expression for x equals negative 4. Well, that would be negative 4 plus 4, and that is equal to 0. And that is the pivotal idea here. If I have an input of x that I plug in and it ends up making it equal to 0, then this would be known as a zero of the expression or the function. Now, if you wanted to find this a long way, and I understand we're using an easy example to demonstrate this, but we'll take this pattern, apply it to the easy example, and then we'll see how this can also work with more difficult examples. So x plus 4, what value of x can I plug in to make this equal to 0? Well, if I want to know that, I can take this expression, and I'm saying I want this expression to be equal to 0. Right? So I set this equal to 0, and then I have to find out, well, what value of x will cause this to be true? And then I have to do a little bit of algebra, isolate my variable, and 0 minus 4 is negative 4. So that would find the 0 of my expression. I set this expression equal to 0, and I find out what value of x is going to make that happen. And this would work even if this was a function, because a function is essentially an expression where what we're evaluating it for is the input and the answer ends up being the output. So if this was f of x equals x plus 4, right now it's a function that can be graphed on a grid. And this would be the y-intercept, and it would look something like that. And since I know that when I set this equal to 0 and solve, I get negative 4, that means that when I plug in negative 4, I get 0. That's the whole idea. When the input is negative 4, the output is 0. That's what a 0 of a function is doing. And that coordinate is right here. That's negative 4, 0. So zeros on my graph are going to be my x-intercepts. They're going to be where my graph crosses the x-axis because they're the spots where the output of the function is 0, right? It doesn't go up or down. It stays right on that x-axis line. So I can find them algebraically by setting the expression equal to 0. I can find them graphically by looking at their x-intercepts. Let's look at one more example. Okay, so I'm going to bring the grid back. And let's say we're going to find the zeros of a quadratic function. X squared plus 6x plus 8. So once again, I'm going to rely on this definition. I understand this definition, and it's going to help me break down what I need to do in this problem. Well, the zeros of a function, right? I'm looking for values of x that make f of x equal to 0. Okay, so I'm going to set this function equal to 0 and find out, well, what values of x will make that happen. Now, if you know anything about quadratic functions, they're shaped on a graph as a parabola, and often, in some cases, a parabola will cross the x-axis twice. So we could have two different zeros here. Now, solving this quadratic equation, we're going to look to factor it. So when we're factoring a trinomial, we're looking for factors of the last number that add up to the second number. So factors of 8 that add up to 6, right? 8 and 1 doesn't work because they add up to 9, but 4 and 2 work out well because they add up to 6. So x plus 4 times x plus 2. And then I can apply the zero product law. I have two numbers multiplying to 0. That only happens if either that number is equal to 0 or that number is equal to 0, and then I'm simply solving two one-step equations. So my zeros would be -4 and -2. And if I wanted to get a rough shape of this parabola on a graph, well, I know where its x-intercepts are because it's going to cross the x-axis at -2, 0, and -4, 0. And because it has a positive coefficient, I know it's going to open up. So it's going to look like a U shape. It's opening up. And we would get something like that. And that would be the general shape of my graph. And that is a walkthrough on zeros. Thank you for watching, and I'll see you in the next one.